Welcome to our channel. Today we're diving into the world of flat Earth theories. Yes, you heard that right. While we celebrate the anniversary of humanity first leaving the gravitational pull of Earth to land on the moon, there are some who still believe that our planet is as flat as a pancake. Now, while I fully support everyone's right to their own opinion, I also believe in the power of scientific evidence. So we're going to debunk some of the most common flat Earth claims with some good old-fashioned facts. We'll journey from the edge of the atmosphere, spoiler alert, there isn't one, to the South Pole, which, contrary to popular belief, is not a giant ice wall. We'll tackle gravity, or the lack thereof, according to flat earthers, and we'll even take a look at how airplanes manage to fly around a spherical planet. Get ready for some cosmic perspective. Please remember to like and subscribe, and feel free to leave any content suggestions in the comments section. Let's get ready to explore the universe, one mind-blowing fact at a time. Have you ever stood on a vast plain and thought, wow, this looks pretty flat? I get it. From our limited vantage point on the ground, it's easy to see why some might think the Earth is flat. But let me ask you this. Have you ever noticed how a ship sailing away seems to disappear hull first, as if it's sinking below the curve of the Earth? That's because it is. As we ascend higher, whether in a plane, a hot air balloon, or even just a tall building, we start to perceive the curvature of our planet. And if you need even more proof, just look at the countless images and videos taken from space. Trust me, the Earth is anything but flat. One of the most common claims of flat Earth proponents is that gravity doesn't exist. Instead, they argue that objects fall because of density. But let's think about that for a second. If gravity were just about density, wouldn't heavier objects fall faster? And wouldn't they all fall in the same direction, regardless of their location on Earth? The reality is that gravity is a fundamental force that governs the motion of objects with mass. It's what keeps us grounded on Earth, what causes the moon to orbit our planet, and what holds entire galaxies together. And guess what? It works perfectly well on a spherical Earth. But Neil, some might say, I've looked out at the horizon and it's always flat. Well, here's the thing about horizons. The human eye has a limited field of view, and the curvature of the Earth is subtle, especially at ground level. It's like trying to see the curvature of a basketball from close up. However, as we gain altitude, our perspective changes and the curvature becomes more apparent. There are countless examples of this, from high-altitude balloon flights to long-distance photography. The horizon might appear flat to the naked eye on the ground, but that's just an illusion caused by our limited perspective. Chapter 4. Photos from space, fake news, or cosmic truth? Let's address the conspiracy theory in the room. Some flat earthers believe that all those stunning images of Earth from space are fabricated, part of a massive cover-up orchestrated by, well, they're not quite sure who. But think about the logistics of that for a moment. We're talking about thousands of photos, videos, and data points collected by multiple countries, space agencies, and even private companies. The idea that all of these entities, many of whom are rivals, are colluding to perpetuate a lie about the shape of Earth is simply preposterous. It would require a level of global coordination and secrecy that's practically impossible to achieve. The evidence is overwhelming. Earth is a sphere, and we have the pictures to prove it. Chapter 5. Airplane flight paths navigating a spherical world. Ever wonder why flights from North America to Asia often fly over the Arctic? It seems like a detour, right? Well, on a flat Earth it would be, but on a spherical Earth it's the shortest and most efficient route. That's because airplanes often follow what are called great circle routes, which are the shortest distance between 2 points on a sphere. If the Earth were flat, airplanes could fly in straight lines between any two destinations. But they don't. They follow the curvature of the Earth, which is why flight times and routes make sense only on a globe. So Chapter 6, the Sun and Moon. Not exactly your friendly neighborhood. Celestial objects. Flat Earth theories often struggle to explain the behavior of the Sun and Moon. They propose that these celestial objects are much smaller and closer to Earth than science tells us. But if that were true, we wouldn't experience phenomena like solar eclipses, lunar phases, or the way the sun's light hits different parts of Earth at different angles. The scientific understanding of a distant sun and moon orbiting a spherical Earth explains these observations perfectly. We can predict eclipses with incredible accuracy, and we understand how the tilt of Earth's axis causes seasons. These are not the hallmarks of a flat Earth model. Chapter 7. The horizon keeps rising to the occasion. One of the most persistent flat Earth claims is that no matter how high you go, the horizon always appears flat. But this simply isn't true. As we ascend in altitude, the curvature of the Earth becomes increasingly visible. Don't just take my word for it. Amateur photographers and balloon enthusiasts have captured stunning images and videos from high altitudes that clearly show the curve of our planet. The higher you go, the more pronounced the curvature becomes. It's basic geometry, folks. Chapter 8. Lunar eclipse. Earth's shadow plays by the rules of roundness. During a lunar eclipse, the Earth passes between the sun and the moon, casting a shadow on the lunar surface. Now here's the thing, that shadow is always round. Always. If the Earth were flat, its shadow would be elongated or even rectangular, depending on the angle of the sun. The fact that we consistently observe a round shadow during lunar eclipses is yet another piece of evidence that our planet is a sphere. It's a simple observation with profound implications for our understanding of the cosmos. Chapter 9. Antarctica, no ice wall. Here, just penguins and research stations. In many flat Earth models, Antarctica isn't a continent at all, but rather a giant wall of ice surrounding the edge of the flat Earth, holding back the oceans. This idea has captured the imagination of many, but it's completely at odds with reality. Scientific expeditions, satellite imagery, and countless first-hand accounts have confirmed that Antarctica is a vast land-covered continent located at the South Pole. It's home to mountains, valleys, and even active volcanoes. There's no ice wall, no edge of the world, just a whole lot of ice and penguins. Have you ever wondered why it's daytime in one part of the world while it's nighttime in another? Flat earthers often struggle to explain time zones, resorting to convoluted theories about the sun acting like a spotlight. But the explanation is much simpler than that. Time zones exist because of Earth's rotation on its axis. As our planet spins, different areas experience daylight and night at different times. This makes perfect sense on a spherical Earth, but is incredibly difficult to reconcile with a flat Earth model. Chapter 11. What are you talking about? Of course, water curves. One of the more baffling flat Earth claims is that water doesn't curve. They argue that if the Earth were a sphere, oceans would spill over the edges, but this reveals a fundamental misunderstanding of gravity and physics. Water, like any other substance, is subject to the force of gravity. Gravity pulls water towards the center of the Earth, causing it to conform to the shape of our planet. That's why oceans and lakes follow the Earth's curvature. It's not magic, it's science. Chapter 12. Stars and planets. Celestial evidence for a spherical Earth. Throughout history, astronomers have used the stars and planets to navigate, tell time, and understand our place in the cosmos. Their observations have consistently confirmed the spherical model of Earth. We can track the movements of stars and planets, predict eclipses, and even measure the distances to other celestial objects. These observations are based on the principles of celestial mechanics and are consistent with a spherical Earth orbiting the Sun. Flat Earth models simply cannot account for the vast body of astronomical evidence that supports a heliocentric model of the solar system. Chapter 13. The Coriolis effect. Proof is in the spin. The Coriolis effect is a phenomenon that causes moving air and water to curve due to the Earth's rotation. It's why hurricanes rotate clockwise in the southern hemisphere and counterclockwise in the northern hemisphere. It's also why long-range artillery shells have to account for Earth's rotation to hit their targets accurately. The Coriolis effect is a real-world phenomenon that's consistent with a rotating spherical Earth. Flat Earth proponents often dismiss it as a hoax, but the evidence is all around us. from the paths of storms to the trajectories of projectiles. Outro, keep looking up. Thanks for watching. If you enjoyed this video, please remember to like and subscribe. Feel free to leave any content suggestions in the comments section. Remember, science is all about asking questions, seeking evidence, and being open to changing our minds when presented with new information. While it's tempting to get caught up in conspiracy theories, the truth is often far more wondrous and awe-inspiring. Our planet is a sphere, spinning through the vastness of space, and that's pretty amazing. Stay curious and keep exploring the wonders of our world.